Welcome back, friends. Today we are going to continue our conversation on slope, but it looks a little different. We talked about slope from a graph. We've talked about which direction slope is headed. Is it positive? Is it negative? Zero or undefined? We've even talked about it from 2 points. What's important to remember is that slope has not changed. Remember, m is what we use for slope, lowercase m, and m equals our change in y, or triangle y, remember that's delta y, change in y over our change in x. It's the same as saying it's the rise over or divided by the run. Remember, we have lots of words for slope. We can say slope, we can say directions, we can say rate, we can use unit rate, we can use constant or proportionality. There's many words, but it's really just asking us, how do we get from one point to another? What is that constant that happens every time? So do you remember the formula that you were working with in our last video? Hopefully you are like, oh yeah. We talked about the change. Remember, y2 minus y1 over x2 minus x1. Well, we're going to use the exact same formula today. We're just going to take the points, though, out of a table. Like, what do you mean the points out of a table? Remember, points and coordinates, we use those interchangeably. So I have x, y. So my 1 is related to my 5, my 2 to my 10, 3 to 15. Well, that means that I could have just wrote those as 1, 5, 2, 10, 3, 15, and 4, 20. And now we just have 4 different coordinates. Now remember, slope is in a linear line constant, which means it doesn't matter which 2 points we use. We practiced that on a graph where we could draw different triangles. We'd always simplify to the exact same slope. So that tells me that in a table that's linear, I can pick any of these. It doesn't matter which ones I use. So I'm just going to start here. I could call this x1 and y1. I could call this x2 and y2. And then I could just go back and use my formula. So my change in y over my change in x, that's what I'm looking for. That's what slope equals. Remember, it's subtraction. So I'm going to go y2 minus y1, which is 10 minus 5. And then I'm going to go x2 minus x1, which is 2 minus 1. 10 minus 5, that would be 5. 2 minus 1 would be 1. And remember, we always write our slope in simplest form. And 5 over 1, well, 5 divided by 1 is 5. So our slope here is actually an integer, so we'd say that the slope equals 5. Now we could use any of these. We also could have taken and used 315 and 420. It wouldn't matter which ones we used. You could pick, you could even use 1, 5, and 420. They're all going to have the same result when you simplify, and your slope would equal 5. So let's take a look here at our next one. Now remember, in a table, the x and y are related. So this is one coordinate. This is a coordinate. So in this table, we have 4 different coordinates, which means we could use any of the 4 to use our formula. The slope is just change in y over change in x. Remember, we're going to go y2 minus y1. I'm going to write that formula again. That's a good practice. y2 minus y1 over x2 minus x1. Y on top, x on bottom. Y in the numerator, x in the denominator. So which ones do I want to use? Well, I'm going to rewrite this so I can make sure I get it right. I'm just going to use the top 2. I'm going to use 420, and I'm going to use 714. And I'm going to label this x1, y1. I'm going to label this one x2, y2. And then I'm going to fill in my formula. I want y2 minus y1. So y2 is here, and from here I'm going to subtract the 20. So 14 minus 20. My denominator is x2, so I'm going to get my x, and then I'm going to subtract the other x. I'm going to go from 7 to 4, so I'm going to subtract 7 minus 4. So we start on our numerator. 14 minus 20. 14 minus 20 is negative 6. 7 minus 4 and our denominator is 3. So negative 6 divided by 3, well, negative 6 divided by 3, that's an even. So our slope would be, now remember, a negative divided by a positive is always negative, and 6 divided by 3 is 2. If this was not an even integer, we would just leave it as a simplest form fraction. All right. Again, we have a table. In a table, we just have a series of ordered pairs or coordinates. There happens to be 4 in this table as well. And we could use any of the 4. So let's go ahead and write our formula. Our slope equals y2 minus y1 over x2 minus x1. I'm going to pick 2 of these points. Again, it does not matter which ones. I'm going to go ahead and just pick the top 2. So I have negative 1, 2, and I have 1, 2. I'm going to start with y2 and go to y1. Make sure when you draw these arrows, you're going the same direction. So y2 minus y1 would be 2 minus 2. x2 minus x1, well, that would be 1 minus, that's the subtraction, and this is a negative 1. 1 minus negative 1. Be careful when you have negatives. 2 minus 2 is 0. 1 minus negative. Minus a negative is the same as plus a positive, and 1 plus 1 is 2. Now let's think. 0 divided by 2. If I have 0, can I divide 0 up? Yeah, I just have more sets of 0. So this would be my slope equals 0. All right, so my last table here, again, how many coordinates do I have, or ordered pairs or points? I have 4. X and Y are related. So I'm going to go ahead and I'm going to remind myself of that by putting those parentheses around them, like, okay, these go together. I'm going to write my slope formula. M equals y2 minus y1, the change in y, over x2 minus x1, the change in x. Again, be careful with these. Make sure you remember that those 2's are just telling you a name. They're telling you where to start. Again, you can pick any 2 points, your choice. I'm just picking the top 2. And then I'm going to label those here. Remember, this is x1, y1. This is x2, y2. I'm going to use my arrows to make sure I keep my direction the same. So y2 minus y1 would be 0 minus negative 3. Careful with that. Minus negative 3. The formula has subtraction. Then I'm going to go back to my x. I have negative 3, and I need to subtract, okay, negative 3, and then I'm going to subtract, the first x was negative 3. So negative 3 minus negative 3. We have to be careful here. We have a lot of minus and negative. Remember, minus a negative plus a positive. So I now have 0 plus 3. 0 plus 3 is 3. My denominator, negative 3, minus a negative plus a positive. Negative 3 plus positive 3. Negative 3 plus 3. Yeah, negative 3, I owe $3. I pay back $3. I don't owe anything. So that would be 0. Now 3 divided by 0 is a little different. This is that magic one that when you put it in your calculator, you go, well, I have 3 and I want to turn it into nothing. Your calculator says, error, you have something, you can't make it into nothing. So here, our slope, if you remember, is undefined. You can't take something and divide it into nothing. 3 divided by 0. If the numerator has a number and the denominator has a 0, or anytime you have a denominator of 0 and you're dividing, your answer is going to be written out as the slope is undefined. So remember, use your formula just like you did with 2 points. It's the same. You're just going to pick any 2 points you would like to out of that table. Make sure you follow y2 minus y1 over x2 minus x1. Simplify all fractions and be careful with those undefined and 0 slopes.